Okay, so the graph above shows the amount of protein supplied by 5 different food products, A, B, C, D, and E, as a percentage of their total weights. The cost of 10 grams of product A, B, are $2, $2.20, $2.50, $4, and $5 respectively. Which of the 5 food products supplies the most protein per dollar? Okay, so we have A, B, C, D, and E. A is 10% for $2. B is 15% for $2.20. C is 20% for $2.50. D is 25 for $4, and E is 30 for $5. So if you divide this out, you get 5, 6.8, 8, 6.25, and 6. So the one with the highest is C. Page number 18, with the trapezoid, it asks how the area changes as the dimensions of the trapezoid change. So what we're going to do is give some dimensions to this. We're going to just choose some random numbers. I'm going to choose 2, 4, and 2 to find the area of the trapezoid as is. So the area of a trapezoid is 1/2 times the height times B1 plus B2. Plugging in the numbers here, the height is 2. Base 1 and base 2, 2 plus 4. And we get 1/2 times 2 times 6. 2 times 6 is 12. Half of 12 is 6 units squared. So the area of this trapezoid here is 6 units squared. If we change the dimensions, it says if B, C, and AD are doubled, so double this to get 4 and 8, and the height is cut in half, then what is the area now? Area equals 1/2 times the height, which is now 1, 4 plus 8 here. Half of 12 is again 6 units squared. So the area actually stays the same, C. Number 19, Boyd grows only tomatoes and raspberries in his garden. Last year he grew 140 pounds of tomatoes and 60 pounds of raspberries. This year, the production by weight of tomatoes declined 20%. So we're going to do 0.20, 20% times 140. And the production of raspberries declined by 50%, so 0.50 times 60. What this comes out to is 28 plus 30, 58. So that's how much less they are growing. So it would be 58 over 200. Gives us a percent decline, so 0.29 times 100 is 29%. A. Okay, the next one, the graph above shows the frequency distribution of a list of random generated integers between 0 and 10. What is the mean of the list of numbers? Mean is the average, so we need to add up all the values and divide by the number of numbers. So here it shows one value at 0, another one at 1. So I'm just adding them all up. There's 3 at 3, 2 at 4, 6, 7, 8, and 10. So if you add these all up, you get 51. Divide by the number of numbers, count these, you get 12, and it divides out to 4.25. 21. Reading the graph, what is the minimum value of the function graphed on the x above for -4 to +6? So in this portion of the graph, the minimum right here is at -2. Okay, now we're going to read a chart. I'm going to zoom out so we can see the whole thing. According to Hubble's data, how fast in meters per second is Galaxy Q moving away from Earth? Well, here is Galaxy Q. The speed over here is 500 kilometers per second. It says meters though, so 1 kilometer equals 1,000 meters. So we're going to multiply this by 1,000. We get, you can add the zeros here. This number, this is in the answer choices in scientific notation, 2, 3, 4, 5. So 5 times 10 to the 5th power. 23, still referring to this chart over here. There are 4 galaxies shown in the graph at approximately 0.9 MPC. So that is right here, these 4. which of the following is closest to the range of velocities of these 4 galaxies. So range is greatest minus the least. So the greatest one, it looks like it's at about 700. The least right here is just under 0, so let's say -1. So we're going to subtract those two numbers and we get 701, which is about 700. 24. Based on the model, what is the velocity in kilometers per second of a galaxy that is 15 MVC from Earth? Well, if I look for 15 on the graph, it is not there. And the graph doesn't expand out that far. But it does give us this equation here. Velocity equals 500 times d. So velocity 500 times 15 is 750 kilometers per second. Next, number 25. Janice puts a fence around her rectangular garden. The garden has a length of 9 feet less than 3 times the width. Here's the garden, 9 feet less than 3 times the width. What is the perimeter of Janice's fence if the area of her garden is 5,670 square feet? Well, area is length times width, so we're going to multiply these two numbers, and that'll equal 5,670 square feet. I'm going to zoom in here. We need to distribute the w to both of those terms to get 3w squared minus the 9w equals 5,670. I'm going to then put this on the other side so we can factor it. I'm going to factor out a 3 to begin with. 1,890. And then I'm going to factor this out. What I need is two numbers that multiply to 1,890 and add to -3. It's going to take some guessing and checking to get these numbers, but once you do the guessing and checking, it comes out to 42 and 45 are the two numbers that you need. And it's plus 42 and minus 45. These numbers multiply to this and add to -3. Now we're going to set both of these equal to 0 and solve for w. The width or the distance of anything can't be negative, so this can't work, and this must be our width of 45. Now we can take w and plug it into this expression here, and we get 126. And then to find the perimeter, you can add or do 2 times 126 plus 2 times 45 to get the entire length around that rectangle, and it comes out to 342 feet. 26. This is something you have not learned yet. It comes up at the end of geometry and also in algebra. We're going to use trigonometry. This is the opposite angle and adjacent. And this is a much larger concept than this. This is probably one of those questions you would just skip or guess on. So we have opposite and adjacent, so we're going to use TOA, so it's tan of angle B equals B over A. Over here we have two inequalities that are graphed. The first one, y is less than or equal to -x. The y-intercept here is 0, so you need something that crosses the y-axis at 0. It has a negative slope, so it's going down this way, so it's this line, and y is less than that, so it's all the area underneath that line. Then here, this inequality here, we're going to get it into slope-intercept form by just dividing by 2, y, that. Our y-intercept is 1, positive slope up 3 over 2. It's this line here. Y is greater than that, so it's everything above that line. We're looking for the overlap, and that is R. 28. This question is a beast. It is insane. Skip it. Next, 29. In a college archaeology class, 78 students are going to to a dig site to find and study artifacts. The dig site has been divided into 24 sections, and each section will be studied by a group of either 2 or 4 students. How many of the sections will be studied by a group of 2 students? So we have 24 equals 78 students. So we have groups of 2 and groups of 4, and that would equal 78 students. X plus y equals the total amount of dig sites, 24. We're going to use systems of equations to solve this. How many of the sections will be studied grouped by 2 students? So we need to solve for x. So we're going to make the y's cancel by multiplying this whole thing by 4. So I get 4x plus 4y equals 96. And then I'm going to subtract this here. So 2x minus 4x is negative 2x plus, that cancels, and then we're left with negative 18 divided by negative 2, and we get x equals 9. And that's your answer there. And on to the last 2 problems. These problems are quite interesting. You may not have seen this before, but I can definitely explain to you the concepts so that you could get it right on the PSAT. So here's the important facts. It says the initial speed of 100 meters per second, so that is your V0 equals 100. And here it says G, or gravity. G is the acceleration due to gravity at 9.8 meters per second squared. It says the arrow is launched upward with an initial speed, and it gives more information here, but here's what the graph looks like, and the graph will help us understand the concepts and get the question correct. Okay, anytime you have an object that goes up and down, the graph looks like this. Time is down here, height's here. It always starts at 0 time and 0 height, and then we don't know what this time is here. The maximum height is right here at the top, and that is exactly half of the time it takes for it to land. So here's what we're going to do. It says, what is the maximum height from the ground? From the ground, the arrow will rise to the nearest meter. We're going to use this equation here for height. Height equals v naught t minus 1/2 g times t squared. In this equation, we're going to put h equal to 0, this point here, and that'll give us the time here and here. We already know it's going to be 0 and something else. V naught is 100. T we're going to solve for. G, acceleration of gravity, is 9.8, and we get t squared. Okay, continuing to solve and simplify this. Get this. Now I'm going to factor out a t here. And then I'm going to put both of these factors equal to 0. T is, we already know that's 0. And then add 4.9 to both sides. 4.9 t to both sides. 100 equals 4.9 t. It comes out to t equals 20.4 seconds. So that's right here, 24.4 seconds. That's not what it asked for though, it asked for the maximum height. So since the maximum height would be at half the time, we're going to use this equation again, but plug in half the time, which would be 10.2 seconds. And then we're able to solve for h. And I'm actually going to move down here to do the work for that. Okay, here we go. I have that set up here. I have the numbers. It comes out to this, which comes out to the height of 510.204 feet. It says, meters. It says, what is the answer to the nearest meter, which would be 510. So your answer here is 510. Now the next question, how long will it take for the arrow to reach its maximum height to the nearest tenth of a second? We've actually already solved this, and it was 10.2 seconds. The halfway point for the entire time. So that is it. That is all of section 4. Again, if you want more thorough explanations or slower explanations, click on the YouTube video I've also linked that has longer and more thorough explanations and also multiple ways to do a problem as well. So have a good day. Bye, guys.